Hi there, in this video we're going to look at converting between mixed and improper fractions. Now you might have forgotten what those actually look like, but I'll show you in the next couple of slides. We have to be really good at this and be able to do it without much effort in order to be able to add and subtract, multiply and divide fractions, which is what follows on from this. So, just a quick reminder that in any fraction, the top number is called the numerator and the bottom number is called the denominator. And at times for this video I will use those words, and other times I will just use top and bottom for short. But they are the fancy words for them, and you hear the word denominator used an awful lot. Okay, so here we have two different looking fractions which are actually the same value. They are called equivalent fractions because of that equal sign in there. And equals in maths means two things are the exact same, and we use it all the time with fractions, equations, all our lines of work, and whenever we move on and we say this equals this. Now, the first one is called a mixed fraction because it is a mixture of the 5, which is a whole number, and the 3/4, which is your fraction part. So it is a mixed number. And then the second one, where it says 23/4, is an improper fraction. An improper just means it's not the way we like it. It's also been referred to as top-heavy fraction, possibly at primary school. So these are the exact same, and we sometimes in maths have to switch between the two very quickly. And to be able to add and subtract fractions, we really need to be able to do this. So the first thing I want to do is I just want to show you visually from a picture why 5 3/4 is 23/4, and this is how I introduce it to class. I say, well, that's 5 holes, so I go and I draw 5 cakes, pizzas, biscuits. I tend to talk about something from the food group, and then I draw 3/4, and then I cut all the 5s into quarters, and then I ask the class, right, how many quarters have I got there? Am I going to sit like in primary school and go 1, 2, 3, 4, 5, 6, 7, 8, and I start doing that very quickly, and the class go, no, that takes ages, just do 5 times 4. And I said, well, why are you doing 5 times 4? And they say, well, there's 5 full cakes, each bit's got 4 bits, so that stands for 5 lots of 4. So effectively what my pupils are doing there is they're working out how many quarters are in the 5 full cakes. And they're getting that the 5 times 4 is 20. And then they add on this little 3 spare quarters that I've got, which gives them the 23/4. Now, there's no way we're going to be able to draw this out all the time, particularly when the fractions aren't as easy as quarters to draw. But what you could do is you could always maybe draw out the circles and say, right, well, that would be 4, that would be 4, if you're really struggling. But there is another way. Remember this sum we did? We did 5 times 4. Well, there's a 5 and there's a 4. So why don't we just do 5 times 4? So 5 times 4 would be your 20. And then we add on the 3. And then what I tell the class is, well, we need to find an easy way to remember it, because some people want to times the 5 and the 3 together and not the 5 and the 4. So I use the phrase big bottoms. We do the big number, which is the 5, times the bottom number, which is the 4. So big bottoms, put on the top. So 5 times 4 is 20, add your 3, gives you your 23. So we're going to practice some of these without drawing them and without having to particularly talk about big bottoms. So here we go, 3 examples. So we start and we times the first 2 things. So you're going to do 4 times 4. And for the first example, I'm going to write down all the working. So we're doing 4 times 4, and then we're adding on the 1. And because we're talking quarters, this will all be in quarters. Now 4 times 4 is 16, plus 1 is 17. So we have 17/4 as an improper fraction. The second one, we're going to do the whole number times the bottom. 5 times 3 is 15. So we've got 15 plus 2. And we were talking thirds there, so it's all over 3. 15 plus 2 is, of course, 17. So we have 17/3 for that example there. And on the last one, we're going to do 3 times 8 is 24. And then we add on the 7. 24 plus 7 is 31/8. So this working down the middle is not essential. That's just me writing out the thought process that goes along with this. And as you get more practice, you should be able to go straight to the final answer. And these are only easy if you're good at your times tables. So like in most of my videos, I like to always have examples that you can go try yourself. So this is a point where you pause have a wee go at these and see if you can get the answers. If not, just keep watching and I'll talk you through the answers. So remember, we're doing big number times the whole number times the bottom. So we're doing 6 times 5 is 30 plus 1, 31 over 5. 2 times 14 is 28 plus 1, 29 all over 14. If you're not sure what the bottom number should be, it's whatever the bottom number in the fraction was. So denominator's not changing. Next one, 9 times 3 is 27, plus 2 is 29, all over 3. 5 7s are 35, plus 5 is 40, all over 7. 4 9s are 36, plus 5 is 41, over 9. 10 times 13 is 130, plus 11 is 141 over 13. Okay. Then we have to do the reverse process. We have to go from the improper fraction back to the mixed one. And the simple way to do this is we go back and do a very simple division sum. Anytime in maths when you have a fraction, that line really stands for a divide line. And some of the topics that you do in maths might have a formula you substitute into, and I'm thinking of speed, distance, time, because I've just done that with my class, and they were used to writing distance divided by time. And then they wrote it as a fraction, so they're getting into the habit of knowing a fraction is always a divide. So to put it simply, what we do is we do 12 divided by 5 in our heads, and you think, right, well, that's 2 remainder 1. But that 2 means that we would have 2 full cakes, and there'd be 1 bit left over. But we're talking fifths, so it means it would be 2 and 1/5. Okay? So the final answer is 2 and 1/5. The second one, we're going to do 16 divided by 3. 16 divided by 3 is 5 remainder 1, so I'm shortening the working again. And we write the 5 remainder 1 as 5 for your whole number, 1 on the top, and we were talking thirds, so it's 5 and 1/3. And then the last one, 21 divided by 6, goes 3 times, which is 18, leaving a remainder of 3. So you've got 3 and 3/6. Now, if I was in a test or an exam and I left that as my final answer, I wouldn't get full marks. And at this point, I asked the class, why would I not get full marks? Well, look at that fraction there. Look at the 3 over 6. I'm not happy with that because always in maths, if you see a fraction that can simplify, you must simplify it. 3 over 6 are both in the 3 times table. They both divide by 3, so that comes down to 3 and 1/2. Now that might crop up in a question, so you need to be aware of it. So hopefully you followed them okay. Again, so as always, this is a point in the video that I would probably ask you to pause, try some again your own. So here we go. If not, just keep watching, here are the answers. And again, it's all down to my times tables. 33 divided by 8 is 4 remainder 1, so 4 and 1/8. 51 divided by 10 is 5 remainder 1, so 5 and 1/10. 17 divided by 5 is 3 remainder 2, so 3 and 2/5. 45 divided by 7 is 6 remainder 3, so 6 and 3/7. 30 divided by 7 is 4 remainder 2, so 4 and 2/7. And 91 divided by 8 needs a wee bit more thinking. Your 8 times table goes 8 10s are 80, 8 11s are 88, so it is 11 with 3 left over, so 11 and 3/8. I hope this has helped. Thanks very much for watching.